Imagine Picasso painting in the dark, guided only by random sparks of creativity, static in his mind's eye, with a stern art critic in the next room sniffing out every forgery. That duel is exactly what happens inside a GAN, or Generative Adversarial Network. Step 1. The generator, our Picasso's brain, wakes up to find nothing but noise. A random vector z, think of it as TV static. This noise alone carries no shape, no meaning, but Picasso's brain transforms it through layers of neurons, each layer refining the scribble. Out pops fake art, which we call X, a smudgy approximation of a real digit, maybe a blurry 5 if we're training on handwritten numbers. Step 2. Fake art travels straight to the Discriminator, our monocled art critic. The critic inspects every brushstroke. Is it a genuine masterpiece or a clumsy fake? He outputs a score Y between 0 and 1, a dial that reads 1.0 if he believes it's authentic, 0.0 if he's certain it's counterfeit. Early on, Picasso's shaky sketches might earn a 0.2. Step 3. We calculate the generator's loss by comparing Y to the ideal target of 1.0. Why 1.0? Because Picasso's goal is to fool the critic into calling his fake real. The gap between the critic's actual score and this perfect 1.0 is our loss. A huge gap means a big bruise to Picasso's confidence. Through backpropagation, PyTorch automatically nudges every neuron in the generator so that next time, the scribble will look closer to the real deal. Step 4. Now it's the critic's turn to train. He examines 2 canvases, the freshly minted fake art and a stack of genuine images from our dataset. For the fakes, he wants Y equals 0. For the reals, Y equals 1. His loss is the sum of being too lenient on fakes and being too harsh on reals. Backpropagation sharpens his monocle, tweaking his weights so he becomes a better judge. Step 5. Notice the feedback loops on the slide. During the generator's round, we freeze the critic's weights and only update Picasso's brain. During the critic's round, we freeze the generators and only update the critic. They alternate like sparring partners exchanging blows. This careful choreography prevents the networks from collapsing into endless confusion. Step 6. As training unfolds, 2 things happen in lockstep. The generator's loss plunges. Picasso learns to paint with conviction, and the critic's accuracy drifts toward 50%. Counterintuitively, 50% is victory. If even an expert can't distinguish real from fake, our generator has truly mastered the style. In game theory terms, they've reached Nash equilibrium. Nobody can improve without the other changing strategy. Step 7. Finally, after enough rounds, we unleash Picasso with fresh noise vectors Z. Each new Z produces a brand new image, never seen before, yet unmistakably from the same family as our training data. That latent space of noise has become a treasure chest of creativity. In Dead, a GAN is a cerebral tug-of-war, Picasso's brain forging ever more convincing fakes, the art critic sniffing out fraud, both leveling up until art and illusion merge into one. This rivalry powers deep fake faces, AI-generated paintings, and everything in between. So next time you see a GAN-made image, remember, behind every masterpiece is a blindfolded Picasso and a relentless critic locked in an endless duel, sparring until they become indistinguishable.